Hello, welcome to the day two training of our introduction to Matlab by Solid Base. Today we'll be looking at Matlab programming basics, where our core objective is to have the basic programming concept, develop Matlab scripts and functions for engineering tasks, implement control flows structure relevant to engineering problem, applying logical operations and rational operators in engineering scenarios. So let us do a quick dive into an additional knowledge in engineering specific variables and data types in Matlab. If you have a scenario where you have this type of statement, variable V, which can stand for either voltage or volume, to be declared with an integer of 8 bits to hold a value or an integer 2. And in another case where you have the same variable v to be declared as 2. What are the core differences between these two variable declarations? These both represent the assignment of values to the variable v with different data types. Now, for the variable being declared with an integer of 8 bits, this explicitly assigns the integer value 2 to the variable v using the 8-bit signed integer data type, and the 8-bit signed integer data type restrict the variable to represent integer values in the range from minus 128 to 127. Now, when we are using this kind of data type declaration or variable declaration, it gives us a limited value at which this variable can store for us. We'll look at a quick example in our Matlab environment. Now we are going to declare the variable v with an 8-bit signed in integer 8-bit data type to hold a value 2. So when we declare this, it returns a value 2 as we've initially assigned. But when we go out of the boundary of this, the size of this integer, having an example v to be int 8 minus, okay, let's give it the value at which it can accommodate is 100 minus 128 to 127. So we are going to exceed that limit and see if it gives us the value at which we stop. So we have 2, 1, 2, 1 to 8, and we'll see if it will give us this value. Now, this clearly shows that the limit at which this variable declaration can hold is from the range of minus 128 to 127. Any value outside that, it will not recognize or stored in the memory. So this is just a clear example of how this variable declaration using the 8-bit signed integer data type works. But if we want to go outside this limit to hold higher values, we can increase the bit size by changing the bit to 16. And gives us our 128. So we move to the next, which is the second declaration. This assigns the integer value 2 to the variable v using the default data type, which is typically a double precision floating point number. In this case, v will be stored as a floating point number with higher precision. When we talk about floating point numbers, they are numbers that can have decimal points for higher precision. So we'll take a quick look at an example in the Matlab environment. So we said v can be declared to have 2. So it gives us 2. And what this actually means is that this is v is equals to 2.000 depending on the precision we want. So Matlab on a default environment, when you declare a variable such as this, it recognizes it as a double floating point data type. Now, if you're dealing with small integers in a limited range, take for instance sensor reading, control signal, and you want to save memory, you might choose to use the int 8 or another fixed value integer data type. This is to help minimize the usage of memory if, for instance, you're carrying out programming for an embedded system. Now, if you need to work with non-integer values or wider range of integers, you use the default data type, which is double, and it is appropriate for such application. Areas such as trying to measure the length, the width, the mass, the volume of a particular mass or object or fluid flow, you want to have a higher precision value. So you go for the double, where you can have decimal point to a certain decimal point or degree of decimal point. Now we quickly look at conversion of data types in Matlab. So data type conversion is essential for several reasons, which include compatibility. Now, we need to convert data type in Matlab because of the compatibility. Now, Matlab supports various data types, and sometimes you need to convert data from one type to another to ensure compatibility in operation of function. We have precision. Different data types have varying level of precision. Now, converting data types allows you to control the precision of your calculation based on the requirement of your application. We have memory optimization. Now, some data types require less memory than others. Now, converting to a more memory efficient data type can be crucial when dealing with large dataset or limited memory, just as the case we saw earlier when I was trying to explain why we use the int when declaring a variable, and in a scenario where we just choose to use a default type, which is double. And we have function input requirement. Okay, certain Matlab functions or operations may require specific data type as input. Conversion ensures that your data is in the correct format for these operations. Then we have visualization. So data types conversion, okay, can be necessary for proper visualization, and okay, in a scenario where you want to have a proper visualization of your result, for example, when converting numeric data to a suitable format for plotting or display for those who are into data analysis and visualization. Then we have error handling. Converting data, or let's say converting data types, can help in handling errors. For instance, if an operation, let's say expect a certain type of input. Converting the data beforehand can prevent runtime errors. Now, we typically see this kind of scenario plays out when you're carrying out your predictive your modeling or predictive modeling, that is using any of the artificial machine learning algorithm. You need to convert some of your data to fit the model. Now that is just how it plays out while you need to minimize errors. And the last but not least, data manipulation. In some cases, you might need to manipulate or process data in a specific format, requiring conversion between different types during data processing pipeline. So now let's look at some brief example of conversions. We're going to look at numbers to text conversion and text to number conversion and get our results. The syntax we use when trying to convert from numbers to text is this. We declare a variable which is var1 to be equal to hold an integer variable 2 with 8 bits signed integer. Then we want to convert this to a text. So we use the syntax int to string. Then put the variable we want to convert. Now this equally plays out when we want to do other variable data type conversion. So in the case where we said at the initial, when you don't apply any int sign or 8-bit signed integer attached to the variable we're trying to declare, it's Matlab by default looks at that variable being assigned to the assigned variable as double. So this is double data type, and so we want to convert it to a string. So we use num to string and assign the variable, then we get our result. In the same way, this is a floating, which is same as a double, but so we use char and put the variable name and apply our command. So if we now want to convert text to numbers, we carry out text to number conversion using the following syntax, which is variable 5 and the character we are assigning to the variable. Now there's a difference between this and a number 4. Now this is a character because it has quotation marks on it. It is in between single quotation marks. This makes it a character. But if there was no quotation marks, or if it was not between quotation mark, then it is a double data type, or simply a number. But in this scenario, we are having a character because it's in between quotation marks. So this makes it a character. And when we want to convert a character to a number, we use the syntax string to number. Same way goes when we want to get a string. We use the syntax. Now, when we try to see our result using the whos command, so in our workspace, the variable they were declared are being shown, and the class of the data type are being displayed alongside with the variables. So for the variable 1, which we initially declared as variable 1, we said it was an integer int 8 of 8 bit, which is clearly shown in the class. And when we converted it to the string, or converted the 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 variable to a character data type, it shows clearly here that we've converted it to a character. This also plays out when we had the double and converted it to character, double to character, and other variables that were converted. I will beg your indulgence to create time and practice this conversion of data type so that you get abreast with how they work, and be familiar with the codes. For we are going to use them in our subsequent um, trainings. So look at the basic commands and examples in Matlab. So uh, we need to look at some of these commands because they will be very helpful when we want to carry out our manipulations or when we want to carry out our coding. Now we have what we call the clear command window. The clear command window provides a clean slate for new commands and outputs. The command here is simply CLC. When we apply this in our command window, it helps us to clear the workspace. Now when we type CLC and hit enter, it clears the command window, giving us a clear place to carry out any other tasks we want to do and makes our work orderly. Okay, so we move to the next basic command, which is clear workspace variable, and this clears the variable from the workspace or removes specific variable from the workspace. During our previous training, I told you what the workspace is, which is this, and it holds the variable with the values of the variable we declared. Initially, we declared v to be 2 to hold the value 2, and you can see it's clearly stated here that it's holding a value 2, but we want to clear this workspace where the workspace, so we use the command clear and hit enter. So you notice that the variable there is being cleared and the workspace is empty. Now if we want to delete a specific variable, we want to delete a specific variable, and initially we declared variables to be a to hold a value 2, 6, and b to hold a variable 5, and we want to delete the variable b from the workspace. We simply type clear and the variable name b, hit enter. So the variable b is gone. So this is how we can clear the workspace window and get rid of the variable we don't need at the time. So then we have the display workspace variable. Now the display workspace variable displays a list of variables in our workspace, and the command to use is simply who. Take for instance, asking someone, who are you? So I'm this person. I come from here. But in the context of Matlab, who simply give us a list of variables in our workspace, and when we type this command on the command window, who, it tells us that the current variable in our workspace, which is in this window here, is a. Then we move to the next, which is detail variable information. Now this provides a detailed information about the variable in the workspace. The command we use for this is whos. Now when we type whos, it gives us further information about the variable in our workspace. This time it gives us the size, the byte, and the class of the variable and possibly the attributes. We have the display variable value or message. I will have a variable, we have a command such as this. I will want to display the variable. This will be more useful when you have scripts, or when you're dealing with live script or the traditional script. So you will come to appreciate the display command. Okay, but for the purpose of this class, we'll just stick to the command window and see how it works. So we have a variable which is holding a value 42, double data type, and we want to display the information that the variable is holding. So we said we can come to a command window and set variable equal to 84, and we say display variable. So it displays the variable which is in our workspace to be 80, which we declared to be 84. We can equally use it to display string or character. So display hello world. So whenever you are trying to impute a string, you make sure that it's in a quotation, either a single or double quotation mark. That enables the Matlab environment to recognize that statement as a string or a character. So have a question mark and we say hello, welcome to Matlab training. Close and hit enter. Okay. Okay. Now, just a quick one. There was a syntax error on the code I initially typed. Instead of the display command, I used deep. So it was a typographical error, which the Matlab environment automatically correct it and prompt me to use the corrected version. So I'll just hit enter, and there it is. Hello, welcome to Matlab training. So we can use this display function to get to access or print a particular statement we want. So we have formatted data printing. Okay, although this might a little bit sound complex, but it is useful. So when you have a variable being declared name John, age 30, so you can use this syntax to get your information that you want to get from your variables. So we use the syntax name Zubair, okay. Now, just as I said earlier, whenever I want to declare a variable that is going to hold either a character or a string, I need to put it in a quotation mark. So that was the mistake I did initially, so I had to come and put it mark, hit enter, and age. I'm not going to tell you guys the age though. So I'm going to put the age, any age. So I can put 50, Okay, or it can be an integer, so of double, and I come to use the formatted data printing, which is going to be f print f. Okay, then I put the name, which is a string. Okay, so I use the name. So you have to have your age and so then you have the name, sorry, age. So I think we got the same information. So you have to be careful when typing your code and make sure your syntax is correct. Now, when you have this typed, you hit your enter button, ensure that everything is correct, and then you hit your enter button. So it gives you your needed output. Name, my name is Beru, age 50. So now the percentage and s, this is just a placeholder for a string. Okay, and then for this is for the percentage and d, this is a placeholder for an integer data type. So the values to be inserted into the placeholder are specified after the formatted string. So we want this want this name to be inserted into the string, and this integer age to be inserted into this placeholder for integer. So after we declare this, it gives us the needed output, which is the name and the age. Now we'll go to the user input command. It prompts the user to enter a data from the keyboard, which is simply the user input. So you enter a number and it displays the result. Now whenever you want to display whenever you are carrying out a display command that has to do with a different data type, the display command only recognizes strings or character data type. So you cannot use a double, float, or integer data type in a display command. So you have to convert it using the command conversion techniques I earlier showed you to convert those numbers to string and print out a result. This is a string, and this is now being this number input user input has been converted to a string because we have prompting that you enter a number. So we're going to look at a typical example. Now I'll clear my workspace, it's looking unkept, so clear it. Then I will type in registration number. I want to get the registration number of student, so I'll type in. Then I said enter your registration number, so input, the input command, then enter registration reg number. reg number. So this has prompted me to enter the reg number, which is 8. Let's say it is 552244. That's the reg number. So the reg number is purely is my reg number is purely digits. So there is no mix of alphabet or any other character in it. So I hit enter. Then I want to use the display function. I want to use the display function to see what my reg number is. So I'll say display. Then whenever I'm having multiple string, I will have to put in my square bracket, and then I will say reg number is reg number is then num to str string, then I said registration, which is the variable registration holding the reg number. Okay, so then I close the square bracket and close bracket, then I hit enter. Okay, I didn't put the display function statement correctly, so here it is. So the reg number is this, which was what I entered from my keyboard. So this is how you use the input command. Now the length of vector, you have a vector declared to hold the value 1 2 3 4 5, and you want to see the length of the vector. So you type in the length, and equally the display function helps you. The same way is holding these are not strings, so you have to convert when you're using the display function. You have to convert it to a string in order to get the values you want. So you need to take note of this. Is very important whenever you want to use your display function, and I'll be leaving this for you guys to practice on your own and get your result and see how it works play out. So now size of matrix. The function returns the size of matrix, and the same way you can input your command, this statement in the command window and obtain the result. It just gives you the size of the matrix, or for a particular matrix you're working on, just for your own information or consumption, or wherever you're trying to use to obtain the size to carry out a particular mathematical analysis. Then for 2D plot, we can use this function to create a 2D plot, which we're going to do. I think it's important because we're going to be using a lot of plot, so it's important to see how you can create a plot. So for this 2D plot, we simply type in the command on our window. Let's clear the workspace and clear the command window. And so we want to get to the 2D plot, so we said our x variable be equal to the line space I think it was line space. Okay, I think it's 0 and 2 multiplied by pi 100. So this, and we go to the y variable. It says is sine. I think it's sine of x. Okay. Then we have the plot. So now we use the plot command, which is a plot x of y, and then we label our axis. So we say the x label to be x. We want to designate it as x, and then the y label we always use the y label to be, I think, to be sine of x. Okay, and then we have our title to be sine function. Okay, and then we go. Okay, just a quick explanation of the code. We declared our x to have a line space of this, which we are coming to see how this actually works, and then our y to be anything the x is, we should just have sine of it, and then we plot it. So in the plot command, we have your x and y, then we label the axis x and y, just like in your graph book you have to label the x and y axis and the title of the graph. So when we hit enter, okay, when we hit enter, okay, here we have to put this, just mistake. So we have our plot, our sine plot, which is this. So this is how we can do a simple plot using the plot command in our Matlab. So we move next to suppressing output. Now you might have noticed that I've been using a particular command, which is the semicolon. Semicolon is very important when we want to suppress a command in Matlab, so that it will make our work neat and clean. Now, an example from what we have here is when I was typing my codes, I made sure that I used the semicolon to suppress output to when I get to the end of my code, and this is very important for me whenever I want to carry out a lot of coding which I necessarily do not need the output at that time. So let me give you a typical example. When I said a is equal to 1, without using the semicolon, and I hit enter, it will tell me that a is equal to 1 outrightly, and possibly I want to carry out other variable declaration. But when I use the semicolon, a equal to 1, semicolon, I've suppressed the output, and then when I can now declare other variable b equal to 2, and I suppress the output. Then I can now say a plus b will give me my needed output at that time. At this point, I need to see the output. So this is how we use it, the semicolon, to suppress the output of our command. So in Matlab, after each command, a semicolon is used to suppress the output. So without a semicolon, the output of the command will be printed on the command window. And in general, so we normally use this a semicolon at the end of every line of code, except the final output or the result we want to see in the command window. That is when we omit the semicolon. So we quickly look at variable declarations in Matlab. So we need to look at what variable declaration is, because we are getting to the core objective of our today's class, which is to understand, carry out some functions in engineering, and to appreciate how the control workflows look like. So to achieve this, we need to look at what variable declaration is. So imagine you have a box and you want to put something inside it. So before you put or something or anything in the box, you need to give it a name. So this name is like a label that helps you to or any other person know what's inside the box. So in programming, a variable is like that box, or it's a container that holds information. And variable declaration is like giving a name to the container, and you tell the computer, hey, I'm going to use this container and I'm going to call it this name. So now when we transition to engineering concept, um, let's say, okay, now transitioning to engineering concept, okay, in engineering or programming, variables are crucial for storing and manipulating data, okay. So let's consider a simple example in Matlab related to engineering context. Now, I want to declare a variable, a container, and I want to name the container radius. So the radius should hold a value 5. Now this is declaring a variable named radius and assigning the value 5 in meters. So using a variable to calculate the area of the cycle, area is pi r square, which the radius is the r in this in the context of the area of a cycle. We have our radius and we square it with the pi variable. So we use this to carry out, this is just a simple demonstration of what a variable is. So a syntax like this that has the variable name, the container, and having a variable is what we call variable declaration. Now we'll quickly look at basic arithmetic operations. We can carry out simple arithmetic operations using Matlab, such as addition, subtraction, multiplication, and division. Now, we'll just take a quick look at this in our Matlab environment, how we can implement these basic arithmetic operations. So clear our workspace, clear the workspace, clear the command window. Addition operation. So we declare our variable. Remember, a variable is like a container with a label. So we said let a container called A hold a value 4. We suppress the output and we hit enter. B have to hold a value 2 and suppress the output. So we carry out a simple operation saying let the variable C be equal to A plus B. So at this point I don't need to suppress out because I need to see what the operation I'm carried out on this variable will look like. So C is 6. 4 plus 2 is 6. Now if we want to carry out our subtraction operation, so we can call the same variable, let D be equal to A minus B. Hit enter. The answer is 2. So for multiplication, we can simply type in E to be equal to A multiplied by B and get our output. E is 8. For division, we can have the division the division to be f to be equal to a divided by b, and we get the output result. So this is how we can carry out a simple arithmetic operation using Matlab. This will help us to carry out further analysis and operations that we want to carry out on our task or program as we go on in this training. We'll be looking at several functions that we'll be declaring for mathematical operation for engineering operations with the aid of this basic arithmetic knowledge. So for now, we'll be having some little exercise to keep us to get ourselves warmed up on what we covered so far in this class.